GCE. GCE.
Hello guys, welcome once more to the GCE panel online. In this tutorial, we are looking at June 2022 Pure Maths Paper 2, question 7 and question 8. So guys, please make sure that you subscribe to this channel so that immediately we upload any material for the GCE to help you, you'll be the first to be notified. Don't just subscribe, but equally click on the notifications bell here so that whenever we upload any content, you will be notified. Thank you so much for always being there, and don't forget to share our videos, like them, and share on WhatsApp and on Facebook. You can equally follow us on Twitter, Instagram, and other platforms. Thank you, and stay tuned to the end of this lesson. So this question 7 reads, given that f of x equals x squared plus 18, or that on x into x squared plus 9, express f of x in partial fractions. Hence, show that the integral from 2 to 4 of f of x dx is equal to ln 4 root 13 on 5. This question carries 7 marks. Now, dear students, there is something I'd like to say here concerning hence, the word hence. Most of the times, when we say hence, we go on to use other methods. But whenever hence is mentioned, it means we have to continue with the previous answer that we had or solution or the previous step or working. Okay? Alright, so now let's tackle this question. So to express this in the partial fractions, the first thing you have to observe is the degree of the numerator here is 2, while the degree of the denominator is 3. That is x to the power 1 plus x to the power 2. Okay? So this power here plus this power, that gives us x to the power 3. So the denominator, the degree is 2, while the denominator is 3, while the numerator is 2. Since the degree of the numerator is less than that of the denominator, it means we can use our normal methods. Otherwise, if they were equal or the numerator is greater, we have to first of all do long or short division or whatever before we proceed. So expressing this in partial fractions, we have x squared plus 18, all that on x into x squared plus 9. So this is going to be in the form a over x plus, and now this other factor here is bx plus c. So we're going to have bx plus c, all this on x squared plus 9. Now we multiply all through by this denominator on the left hand side, and you'll be left on the left hand side with x squared plus 18 to be equal to, on the right hand side, a times this denominator will give us a x into x squared plus 9, all that on x. So we'll be left just with a into x squared plus 9. And when we multiply by this, the denominator cancel out this, and we'll be left just with all of this numerator bx plus c times x. So this is what we have. We can use the cover-up method, but it's going to be a bit difficult here. So we are going to work with equating coefficients, okay? So I'm going to expand this right-hand side and bring together coefficients of x squared. So we're going to have ax squared plus, this is bx squared. So I'm going to have a plus b, all of that times x squared. Then 9a is a constant, and c times x is a polynomial of degree 1. Okay. So here now, equating coefficients, we see that on the left hand side, the coefficient of x squared is 1, and on the right hand side, the coefficient of x squared is a plus b. So from here, a plus b is equal to 1. Now, the constant on the left hand side is 18, and the constant on the right hand side is 9a. So from here, it implies that 9a is equal to 18. Now, the coefficient of x on the right hand side is c. There is no term in x on the left hand side. This implies that c is equal to 0. So from here, c is 0. A will be 18 on 2. That is 18 on 9, which is 2. And if a is 2, then b should be negative 1. Okay? So a is 2, b is negative 1, and as we have already seen, c is 0. Therefore, f of x can be written as being identical to 2 over x minus x on x squared plus 9. Okay? Note that our b is negative 1, so we have written a negative 1 here. So you can see right plus negative 1, but it will not make sense. So this is f of x. Now they say hence, show that this equals that. Hence means you should continue with what we have here, which means if what we have here is wrong, it will become almost impossible for us to prove the second part of the equation. We are going to lose these 4 marks. So we have to make sure whenever we have hence, we have to make sure that the first part we are working with should be correct. Because if it's not correct, That hence for the second part is going to be mystifying mathematics. Okay, so here we are going to continue with this, the B part. The integral of 2 to 4 of f of x dx will be equal to the integral of 2 over x minus x over x squared plus 9. So we are going to separate this, and we are going to have the integral from 2 to 4 minus the integral from 2 to 4 of x over x squared plus 9. But we can work with all of this directly. Okay, so let's look at this. The integral of this first part, that is from of 2 over x, this is just going to be 2 ln x, right? So we are going to have 2 ln x, so minus the integral of, so when we differentiate this 1, we are going to have 2. So we are going to bring out 2, work it out. Then we factorize and we continue, like we can see here. So when we continue this integral, we are now going to have 2 ln 4 minus a half ln 5, that's for the first part. And for the second one, we are going to have 2 ln 2 minus a half ln 13 from 2 to 4. So this will be equal to ln 16 minus ln 5, because 2 ln 4 is the same as ln 16. That is, I will bring the 2 behind, 4 to the power with 16. A half ln 25, the same as the ln the square root of 25, which is ln 5. Minus 2 ln 2, so minus ln 4. Then minus minus is plus, because there is no number separating them. So this is going to give us a half ln 13, which is the square root of the ln of the square root of 13. Okay, so that is plus. Okay, right. So when you simplify this, you are going to have ln 16 times root 13. So this times this, because they are plus. 16 times root 13, all that on 5 times 4. And this is going to give us ln 4 root 13 on 5 as required. Okay, so I am sure you may see that maybe like it's like you have skipped 1 or 2 steps after this dx here, but that's okay. Make sure that you include those steps. I think when you're working on this, we skipped 1 step, that's why you see this, but it's not actually a call for alarm. Make sure that you put that step into consideration. Guys, please, as you watch this video, make sure that you share on Facebook, on WhatsApp, and different platforms. We equally have the solutions of this material in PDF. You can just contact the number that you see below, or the link below this video, or you go to the website, you're going to see a WhatsApp button there. You contact that number to buy these equations from 2015, I think, to 2022 for math mechanics and math statistics. It is low cost. If you want to buy the hard copy, equally contact us. If you want to supply the copies, you make sure that you meet us. We have online classes on Zoom that are going on. You can see the classes live. Guys, please join us so that we prepare for the GCE and make the world a better place. Thank you so much, and God bless you as you prepare your exams. Don't forget to visit our website to download past GCE equations and exam materials as you go. Bye-bye. But as you are going, have you subscribed? Did you share this video? We are waiting. Subscribe and share.
GCE panel.